In this video, we're going to be taking a look at integration with trigonometric substitution. So the problem we have here is the integral of the square root of 9x squared minus 25 divided by x cubed dx. And it says that x has to be greater than 5 over 3. That's because anything less than 5 over 3, if you plugged it into the square root, would give you a non-real answer. Okay, so let's do our substitution. So I'm going to substitute x is equal to 5 over 3 secant theta. Okay, so 5 over 3 secant theta. And I want to state that theta must be in the first quadrant. So from 0 to pi over 2. I'm not going to include pi over 2 because if I did, then this would turn into a 0. And then if you put a 0 here, you'd be dividing by 0. So you don't want to do that. All right, so dx, take the derivative, dx is going to be equal to 5 over 3 secant theta tangent theta. Okay. And then one more thing, I'm going to take this square root that we were given, this 9x squared minus 25, and I'm going to substitute in the x that we just picked for it. That's 5 over 3 secant. So we've got square root of 9 times 5 over 3 secant theta squared, because this is getting squared, minus 25. Okay, so that will be equal to, let's see, the square root of, let's see, this gets squared, all the stuff gets squared. So here's the 9 that's out front, times 25, times secant squared theta, divided by 3. Nope, not divided by 3, divided by 3 times 3, right? Which is 3 squared. I'll just say 3 squared there. That is a 9. And then minus 25. Okay, so the 3 squared and the 9 will cancel each other out. So we're left with the square root of 25 secant squared theta minus 25. If I factor that 25 to the front of the square root here like this, I'm left with secant squared theta minus 1. Okay, given that, I know that secant squared theta minus 1 is equal to tangent squared theta. So I have 25 tangent squared theta underneath the square root, which when I take the square root of it, that's going to be equal to 5 tangent theta. So I know that 5 tangent theta is equal to the square root of 9x squared minus 25. Okay, so that is going to be what I'm going to substitute in place of this up here. Okay, all right, so let's start our substitution. So we know we just found this, that's 5 tangent. So I have 5 tangent theta. Okay, and then I have an x cubed on bottom, so I'll substitute this in, 5 over 3 secant theta cubed. And then, of course, we have dx, which is this, 5 over 3 secant theta tangent theta, and then d theta at the end. Okay, so to look at this for a second, you might see that this 5 right here, this 5 over 3 secant theta and this 5 over 3 secant theta are the same term, just this one is getting raised to the third power and this one's not. So I can cancel those out. So there goes that. And I can reduce this down to a 2. Okay, so that gives me the integral of 5. Now we have tangent times tangent, which is tangent squared theta. And then on bottom, I have, let's see, I'm squaring, so 25 over 9 secant squared theta, d theta. Okay, I'm going to take those numbers out, and I'm also going to flip this bottom fraction right here and multiply it. So it'll become 9 over 25 instead of 25 over 9 times the 5 that was already there times the integral of tangent squared theta over secant squared theta d theta. Okay, reduce one more time. We've got this 5 and that'll reduce that to a 5 down there. Okay, so we've got the integral of 9 over 5 tangent squared theta over secant squared theta d theta. Okay, so now I'm going to take this tangent squared theta and I'm going to use the identity, same way I did over here when we converted it from secant squared theta to tangent squared, from this to this. I'm going to go back the other way. So now I'm going to write, instead of tangent squared theta, I'm going to write it as secant squared theta minus 1. So it'll be 9 over 5 out front times secant squared theta minus 1 over secant squared theta. Okay, and that's d theta. And now if I split that up into two fractions, here's the 9 over 5 out front. It'll be secant squared theta over secant squared theta. That up. So that's going to be 1. That's this one. And then minus 1 over secant squared theta. D theta. Okay. Note that 1 over secant squared theta is cosine squared theta. So you get 9 over 5 times 1 minus cosine squared theta. D theta. Okay, and then one more identity, we can change that into 1 or just a sine squared theta. So it becomes 9 over 5 times the integral of sine squared theta d theta. Okay, so if you want to see how this sine squared theta derivative is derived, you can watch my other video for that. I will link it in the comments. But for now, we're just going to write down what the derivative is. So here's the 9 over 5. Okay, and then we have theta over 2, and then minus sine 2 theta over 4. Okay, and of course you'd have a plus c on the end of that. Okay, let's go ahead and distribute this stuff. So we get 9 over 5 times this would be 9 theta over 10. Okay, and then this one would be minus, let's see, 9 theta, or not theta, 9 over 20. So 9 on top, 20 on bottom, and then sine 2 theta plus c. Okay, so I want to convert this back to x's. This is the answer to the integral, but I need it converted back to x's. So I need to do some substitution backwards. Before I do that, I want to exchange this sine 2 theta. I'm going to exchange it for 2 sine theta cosine theta. So here's the first term. It's not changed. The second term, instead of 9 times this, I'm going to write 2 sine theta cosine theta. That's a trig identity over 20 plus c. Okay, so that is this right here. Sine 2 theta is now this. Okay, and the 2 that's inside there and the 20 on bottom will reduce. So I get 9 theta over 10 minus 9 sine theta cosine theta over 10 plus c. Okay, now that we have that, I want to do some substitution. So I'm going to do that on a separate sheet of paper here. So here's what we're doing. We know that this is true. Let me write this down on a separate sheet of paper. We know that x is equal to 5 over 3 secant theta. Okay, given that that's the case, I can solve this for theta. All I have to do is multiply the 3 and divide the 5. So it would be 3x over 5 is equal to secant theta. Okay, and if I flip this fraction, and it'll flip this as well, so it'll turn into a cosine. So 5 over 3x is equal to cosine theta. And then if I take the inverse cosine, I get theta is equal to cosine inverse of 5 over 3x. Okay, so that's what I'll do for that first term, the one that just involved the theta right there. I'm going to put what I just found right there. Now I need to figure out the other part, which is what is sine cosine. Okay, so here's how we're going to figure that out. What is sine cosine? I do know from earlier that 5 tangent theta is equal to the square root of 9x squared minus 25. Okay, so first solve this for tangent. So I divide that by 5. So tangent theta is equal to the square root of 9x squared minus 25 divided by 5. I remember that tangent is the same thing as sine over cosine. So sine theta over cosine theta is equal to all this stuff, 9x squared minus 25, and then 5 on bottom. Okay. Now I want to figure out, what I'm trying to figure out is what is sine theta cosine theta, right? Right now I have sine theta divided by cosine theta. I don't want that. So in order to get a cosine theta on top, I can multiply both sides by cosine squared theta. If I do that, one of these goes away with this one, and we're left with sine theta cosine theta, which is what I wanted. And on the other side, I have all this, but I still have that cosine theta, which is, I'm trying to get rid of that. But luckily, I already know from earlier what cosine is. Cosine is this right here. Okay, so I can sub in the 5 over 3x here and just square it. So that's going to be equal to the square root of 9x squared minus 25 over 5. And now for the cosine squared, that's going to be times 5 over 3x squared. Okay, so that would be the square root of 9x squared minus 25 over 5 times 25 over 9x squared. Okay, I can reduce this. It becomes a 5. It becomes a 1. So you get sine, move up a little, sine theta cosine theta is equal to the square root of 9x squared minus 25 divided by, oh, don't forget the 5 there. There's my 5. And then divided by 9x squared. Okay, so that's going to be, these two things are going to be my substitutions. When I go back, that's what I'm going to put in place of theta. And this is what I'm going to put in place of sine theta cosine theta. Okay, so here's the problem. Back to where we had it. Okay, so I will take this right here and I'm going to put this in its place. So it will be 9 and then this stuff, cosine inverse of 5 over 3x. Okay, and then divide by 10. That takes care of that term. That one's done. And then minus 9. And then this stuff we just found is this. Okay, so we have times 5, square root of 9x squared minus 25. And then on bottom we have 9x squared. And let's see, what else am I missing? Oh, the 10. The 10 came from here. So 10 times 9x squared. And then plus c. All right, we're almost done. Just need to clean this up a little bit. First term doesn't need to be cleaned up, so I'll just write it again. So that's 9 cosine inverse 5 over 3x divided by 10. Oops, that doesn't look so good. Divide by 10. Okay, and then this, what can I reduce? The 9's go away, right? The 5 and the 10, these become 1s. This becomes a 2. This is a 1. Okay, so all those numbers just go away. We're left with the square root of 9x squared minus 25. And then on bottom, we have the 2 here and then the x squared. So 2x squared and then plus c. And then the problem is complete.